Now, if all else fails and we don't manage to get to where we want to be in 2050, we don't manage to move to renewable energies fast enough and everything else we've spoken about, some people are talking about a topic of we call geoengineering or climate geoengineering, which actually means to look for options that would actually involve large-scale engineering of the climate, of the environment, in order to both combat climate change and counteract the effects of changes on the climate. Most scientists aren't that keen on talking about this because it kind of gives an excuse to the politicians to wait and see. Let's wait a little longer, see if there's really a problem. And if there's a problem, then we've got geoengineering as a backup to solve the problems. But we still need to discuss it, and you need to know about it, and so we'll talk about it in this unit. And geoengineering can be divided up into two different types of geoengineering. The first is what we call carbon dioxide management, and the other one is solar radiation management. These are actually very different, both in the timescales and actually what they do. The carbon dioxide management is to manage the carbon dioxide in the atmosphere and to remove it artificially from the atmosphere. We've already spoken about the carbon capture sequestration. That's one type of geoengineering, where artificially we take it out of the atmosphere. And the solar radiation management is to manage the solar radiation coming into the planet. And the basic idea is to reduce the amount of solar radiation coming in so that the temperatures will go down. We will cool the planet. But the big difference really is the timescales. The carbon dioxide management will take decades to have effects because we have to remove huge amounts of carbon dioxide, and it takes a long time. So this is a slow process, which maybe we need to start already today. Solar radiation management is something very fast. We can see results in months maybe. And both of these have problems that we may not know the side effects. There may be surprises. And therefore, scientists prefer not to play around and artificially play with the climate and rather deal with the core of the problem, which is the fossil fuels and the emissions of greenhouse gases. But nevertheless, we should talk about this because you're going to be hearing about it more in the future. So here we can see some of the examples of geoengineering which have been proposed by different groups around the world. In the yellowish-orange boxes, you can see ideas for solar radiation management, and in the lighter blue boxes, these are related to the carbon dioxide management. So let's just talk a little bit about them. These little snowflakes in the circle represent how much impact they will have on the climate. The more of these snowflakes, the larger the cooling effect. The dollar signs are how expensive this would be. More dollar signs, more expensive. The readiness, how ready we are to implement these ideas. And all of these have downsides. All of these have problems and maybe surprises in the future, and therefore we need to know the caveats of using any of them. If we start at the top, the most really extreme is putting mirrors in space. Sounds fairly easy. Let's just put a bunch of mirrors in space which will reflect the sunlight back to the sun. Reducing the sunlight by just a few percent will be enough to cool the planet and offset the greenhouse gases in the atmosphere. Well, this is something which will cost trillions and trillions of dollars. A huge cost. Will take us maybe decades to centuries to build. You have to build it in space. We'll see a little bit later where we have to build this. But we don't know what the side effects will be on the climate. And all of the solar radiation management schemes don't obviously impact the carbon dioxide in the atmosphere. And so we'll continue to still see ocean acidification impacting coral reefs and life in the oceans. And therefore, they may solve the temperature, but they're not going to solve the whole problem. Other solar radiation management schemes are like cloud seeding by putting extra aerosols, particles into the clouds. We spoke about how we can change clouds in the lesson on the clouds, but we could brighten clouds, make them whiter. If they're whiter, the albedo will be higher, reflect more sunlight, and therefore they'll cool the climate. The same with reflective crops and putting aerosols in the stratosphere, which we've also spoken about, and I'll touch on in a few minutes. All of these basically reflecting sunlight back to space and will cool the climate. And the carbon dioxide management in the lower boxes, some of them we also spoke about the biochar. Biochar can actually take it out, but the actual cooling effect on the climate is fairly small because we have to do this on a huge scale to have an impact on the climate. Foresting or reforesting, we've seen this could have a big effect, but again, we need very large areas to produce new forests, artificial trees, which will take out the carbon dioxide, and one on the bottom right, the ocean fertilization, which also, in theory, may work, but it will have a small cooling effect unless it's done on a huge scale, which may have, again, unknown side effects. So let's talk a little about each of these, or some of these. So the first one, again, the ocean fertilization, the last one we spoke about on the previous slide. We've spoken about the oceans. We know the oceans absorb carbon dioxide. Carbon dioxide goes into the ocean and comes out of the ocean. There's a huge flux on an annual basis. Photosynthesis in the ocean takes up carbon dioxide. And we can see here that once we have photosynthesis, we can have organic carbon, inorganic carbon, particular carbon, which can fall down to the bottom of the oceans and can be there for centuries. And this is a way to remove carbon dioxide from the oceans, from the atmosphere. So if we can add a type of fertilizer to the oceans, in this case we can see iron, adding iron to the oceans, this can enhance the photosynthesis by phytoplankton in the ocean, which will capture carbon dioxide. Eventually the dead phytoplankton sink down through the thermocline to the deep ocean, and they can remain there for centuries at the bottom of the oceans. So the wish is that we can remove additional carbon dioxide from the atmosphere. We can go back to phytoplankton in the oceans, populations of historic levels, reviving fisheries and sequestering carbon dioxide, removing it from the atmosphere. Unfortunately, there are many risks as well. And some people said maybe that the iron could deplete the oxygen in the deep oceans, and this could affect the food chain, and eventually maybe the carbon dioxide will come out of the oceans and return back to the atmosphere. So there could be some surprises which we're not expecting, and therefore again maybe we don't want to play with the climate and do these artificial geoengineering experiments. The next idea is cloud seeding. We've spoken about clouds, but especially low clouds, which are very reflective, have high albedos. Maybe we can send ships around the oceans, ships which are basically run on solar energy, will pump up water from the ocean, spray. These will evaporate, produce little particles which will go into the clouds, and they will brighten the clouds and cool the planet. And we've seen that naturally this happens, well, maybe not naturally, but we've seen this from satellite images. We've spoken about this before, that these lines we see in the satellite image are ship tracks. These are the locations where ships have actually gone underneath clouds, and due to the aerosols released from the ships into the clouds, these aerosols produce much smaller droplets. And when we have much smaller droplets, we have much more scattering and reflection of light, and these clouds then become brighter. And we can see them here in the satellite images, the white clouds over the background darker clouds. Can we do this on a global scale to brighten clouds, make them whiter, which will reflect more sunlight and then result in the cooling at the surface? Maybe, but maybe this will also have negative effects on rainfall patterns around the world, circulation, and therefore maybe we don't want to play with this. The next topic is putting aerosols into the stratosphere. We've spoken about this in the lesson when we spoke about the volcanoes. When we put sulfur into the stratosphere, these can produce tiny little aerosols, tiny little particles, which can reflect the sunlight out to space. So adding the right type of particles into the stratosphere can increase the amount of reflected light and cool the surface. And we spoke about it in the class on the volcanoes, that naturally this happens in the atmosphere when we have huge volcanic eruptions like we had in 1991 from Pinatubo. And we can see throughout the 20th century, also when we look at the temperature plot of the globe, these vertical lines in gray are when we had the major volcanic eruptions, Santa Maria, Agung, El Chichon, Pinatubo. And after each volcanic eruption, we see this cooling, the planetary cooling for a number of years. On the right, we can also see the image of this very thin layer of these particles in the stratosphere after the eruption of Pinatubo. And so we have clear evidence that this would work if we do this artificially, that we can actually cool the planet similar to a volcano does if we put these particles into the stratosphere. And if we look at an example of a simulation for climate change with and without these particles in the stratosphere. So on the left, we can see the predicted temperature around the planet in 2040 and below in 2080. And this is similar to what would happen if we double the carbon dioxide in the atmosphere. On the right-hand side, we can see the same increase in greenhouse gases, but by adding an extra 2 teragrams of sulfur every year into the stratosphere, we offset this warming. And you can actually see quite a few areas with the blue colors on the right-hand side, showing that the temperature, the global temperature, will be also around about zero change when we combine both the greenhouse gases and these aerosols from the volcanoes through the sulfur in the stratosphere. And therefore, this could work, and the models show that we could actually cool the climate putting these aerosols in the stratosphere. The last option is maybe the most outrageous, and this is the space option, putting reflectors or diffraction gratings in space. The location of these mirrors, reflectors, has to be at a specific location in the orbit outside of the Earth. And on the bottom left, you can see the Sun and the Earth. And this point we call the Lagrangian point 1, L1. There are many other Lagrangian points. But this L1 point is exactly between the Sun and the Earth. And therefore, if we put mirrors at L1, they will block out some of the sunlight coming to the Earth. This point is exactly where the gravity of the Sun and the Earth balance each other, and therefore we don't need any extra forces to keep the mirrors at that location of L1. So putting these reflectors at L1, we can decide how many to put there. This will block out part of the sunlight, reducing the flux of energy coming to the Earth, and will cool the planet. So on this plot, we can actually see all these different ideas for geoengineering plotted on a graph which shows the costs on the bottom going from very cheap to very expensive, and on the y-axis, the actual potential of cooling the planet from a low potential to a very high potential. And these circles show us, in the color of the circle, show something about the safety. If they're red, we're not sure that they're very safe. If they're green, they may be not going to damage the climate too much. And the size of the circle also represents how fast we can implement this. The bigger the circle, quick implementation, smaller circle, slow implementation. And so we can see the different things we've spoken about. If we look, for example, at afforestation, so afforestation has not such a large cooling effect, but it's fairly cheap to do. And if we go to the stratospheric aerosols from the volcanoes, we can see it has a very large cooling effect. It's not that cheap, but it's also not that expensive compared, say, with the space reflectors. So here we can see the distribution of options that we have for geoengineering based on both the costliness and also how much of an impact they'll have on the climate.